Good morning, students. Today we'll be talking about the composition of functions. This is read f of g of x, and that's called the composition of those two functions. It's a way of combining two functions. So far, we've added, subtracted, multiplied, divided functions, all the operations, but this is also a pretty unique way of combining them. What it really means is one function is going to be substituted inside of the other function. So in this one, the g function is performed first, and the output of that function is the start of the f function. So it goes in place of the second function. In other words, if I start with some x, the g function is taking me to some output. And then that output is then the input of the next function, which is the f function, and that will take me to its final output. G of f of x, notated like so, is simply g of the f function inside of it. Okay, the purpose of this is to show that sometimes placing one function inside of the other is not commutative. So if it is, it's going to be a special case that will relate the previous lesson in this one. Okay, so let's take a look at the worksheet from the homework. I selected two problems from the homework worksheet, number 1 and number 5. In both problems, we're asked to find the composition of two functions that are defined for us. F of x, the first function, is x minus 5, and g of x is 4x plus 3. So to find the composition of f of g of x, that is like saying f is the main function, and the g function is going to be placed inside of it where the x is, where as if it's being substituted for its input. So the f function is x minus 5. I'm writing that function, but I'm not writing the x. I take out the input, the x, and I leave a space held with parentheses. Then I place inside the g function inside of the outside function. Okay, now all you have to do now is simplify using distributive properties and combining like terms, nothing to distribute. I'd still like to see the parentheses just in case there were some operations to show, and combine like terms. I'll relabel that is the f of g of x, the composition of functions. In example number 5, we are asked to find the composition of h of g of x, which means we're going to start off with the h function. We're going to place inside of it for its input, we're going to place the g function inside. Another way of thinking about it is we begin with the g function, the output of that becomes the input for the h function. I like to begin by writing the function that's on the left, which I call the main function. I write it out with the input removed. The input is the x. Notice I write the coefficient in front of it, including the sign, the exponent on the outside of the parentheses. And this is important to be able to show the order of operations when we do simplify. Inside the parentheses, I'm going to put the entire first function, 2x minus 1, entire g function inside. Get substituted in place of the x of the second function. Okay, then we'll just follow the steps of order of operations. I'm going to square the binomial, 4x squared. Outside product is 2x, inside product is also negative 2x, so that combines to minus 4x, plus negative 1 times negative 1 is 1. What I did there was 2x minus 1 FOILed out. I'll bring down the negative 2 being multiplied and the minus 5 on the outside. Negative 8x squared plus 8x, distributing the negative sign, minus 2 minus 5. The last step, combining like terms, negative 8x squared plus 8x minus 7. And there we have the composition of h of g of x. The assignment is to do the evens on that worksheet, which I'm calling number 11. You guys can do it.